All right, for our last kind of proof examples, we have to kind of understand a couple more theorems. We've talked about intersecting lines that form a linear pair, but this theorem states that if you have intersecting lines that form a linear pair that are congruent, that means they're equal, they have the same measure, then the lines have to be perpendicular. And that makes sense because if we know a line is 180, okay, a straight angle. And so if they're congruent, that would mean that this side would have to, my pen is not working. Is it not on? I don't think it is, sorry. That would mean that this side would have to be 90 and this side would have to be 90. So you have a total of 180. Because if it's a linear pair, it equals 180. Okay. And that's if you just need to see that. Sorry. So that means that they would have to be congruent. And if they're both 90, then that's proving this upside down T means perpendicular. Now we're going to use this theorem and also another theorem. Go to the next theorem here, next page. It says if we have two lines that are perpendicular, then the intersecting forms right angles. Now, if I have two lines intersecting, let's put a point in intersection. You don't have to have that to show that. And I show the box for one angle, then I'm showing it for all four. So if I know the lines are perpendicular, then I know all four angles are going to be right. We're going to use these theorems on our last example of parallel line proofs here. And we're going to use the answer reason bank here at the bottom because they've given us all the statements. So remember, the first statement is always given. Sorry, given here. And I can cross that out down here. And what they've given us is the two lines RP, or the ray, excuse me, RP and RN are perpendicular, and they've already marked it for us in the diagram. Then this is, well, if I know they're perpendicular right here, we know this angle PRN is a right angle, okay? And that goes back to what we just talked about up here. Two lines are perpendicular. So we're going to use this theorem. Or that theorem, I think it was 3.9. Yeah, there it is. We're going to use this theorem here on line 2. So perpendicular lines, sorry, intersect to form four right angles. That was the 3.9. So if you use this, put these in here. Now, if I know I have four right angles, well, to be a right angle means you're going to have a measure of 90, right? So now I'm stating that this angle that we know is right equals 90. And let's see if we can recognize a possible reason for that. Exactly. Definition of right angles. So we're going to put that in line. Definition. I'm going to abbreviate that. A right angle. Abbreviate right as well. All right, so now I'm looking at this diagram in here. We also have labeled angle 5 and 6. And we know PRN is a right angle. And we know 5 and 6 are adjacent inside of here. So I can say the measure of angle 5 and the measure of angle 6 is going to make up this angle PRN. And whenever I have adjacent angles side by side, we did this at the very beginning. We have what we call the angle addition postulate. I'm adding those angles to make the whole. Part plus part equals the whole. So we're going to put our angle addition postulate in our line 4. I'm just going to use the angle symbol, abbreviate addition, postulate, abbreviate postulate. Okay. So we know that PRN is 90 degrees right here, sorry. And so I'm now going from 3, 4 to make up that 5, and hopefully you see the thing they have in common, the name PRN. So I can substitute that with that measure, 90, and we are using right here the transitive property of equality. Now, some people say substitution. I mean, it's the same thing. I'm fine with that. And always what we're trying to prove, which was right here, angle 5 and 6 are complementary, should be in the last line, which it is. We need to come up with a reason why I know they're complementary. Well, if I know the measure of these angles added up equal to 90, that is our definition of complementary angles. Okay. And we have used all of our reasons. Now the last little theorem here is kind of combining that theorem 3.9 and complementary angles. So if two sides of adjacent acute angles are perpendicular, so because I know it's perpendicular, I know I'm going to have this box right here, and the angles are complementary. So if I know I have a perpendicular line and these two angles side by side, they're adjacent, then they're going to always be complementary, right? So now that you have completed the notes of some guided examples of proofs, we're going to ask you to go on to the practice, all right? Which you'll have, oops, sorry, which you're going to have some reasons and statement bank for each one. And so try to get through and let's check your understanding and we'll turn this in. All right, thanks.